In this program, we're going to take a look at two kinds of tree trimming commonly performed by a power company. They are line clearance tree trimming, normally used to prevent power outages and keep customers online, and the emergency tree trimming, often needed to get a circuit re-energized and the customers back online. Along the way, we'll identify some of the physical and electrical hazards that are typically encountered while trimming trees around energized equipment. Let's begin by defining just what we mean when we talk about tree trimming. Then we can take a look at some typical examples of tree trimming performed by most electric utilities. Of course, the simplest definition of tree trimming is to cut and remove parts of the tree. However, this definition doesn't take into consideration many important factors, such as the health of the tree, property value, and customer goodwill. As a matter of fact, your company's policies concerning tree trimming are often determined by customer goodwill, as well as easements, laws, and other agreements between the local government, property owners, and the power company. So, for our purposes, let's define tree trimming as the safe removal of enough growth to provide uninterrupted electrical service to customers while maintaining good customer relations. Of course, from the company's point of view, the best way to avoid power outages caused by trees is to secure tree-free routes when building new construction. This is often a good practice, even when the distance involved is longer than the distance across the treed area. The cost of the extra materials needed to build the longer route and compensate for voltage drop can be quickly offset by the savings in tree trimming expense. The frequency of tree trimming in any area and the clearance required depend on many variables. Some of these variables are the voltage level of the lines, the types of trees involved, the climate and weather, and the location and construction of the lines. In some cases, the amount of clearance needed is largely dependent on the importance and location of the line. For example, when dealing with high-voltage transmission lines or any lines in an area that is difficult to reach with tree trimming equipment, it's often wise to clear the right-of-way altogether. Removing any danger trees that might interfere with the lines prevents having to periodically trim them back. In other areas, enough clearance must be created to protect the line for the duration of the trimming cycle. The required clearances are often given in chart form, like this one, so that the information is readily available to each employee. Of course, some trees grow faster than others and must either be trimmed back farther, trimmed more often, or both. For instance, a 4-year cycle requires 5 feet of clearance between the top of a slow-growing tree and the bottom of a distribution line, while a fast-growing tree would require 11 feet of clearance on the same 4-year cycle.